Hi, students of mathematics. You're back. I'm wearing a tie, so formal. We got two more examples to take care of from lesson 87. So this will be part B of this one. The second example I'll need to massage a little bit for you and show you where things come from. We'll show you some shortcuts. Well, we'll talk about some tools that we're going to put in our math tool bag. So we're going to start off with a question that's a lot like ones we've had in the last episode. We got four things. We're breaking it up in half and factoring separately, and then regrouping these things. And I could put this together in lots of different ways, but I'm going to keep it the way it is right now. I'm going to factor the front half, and then we'll factor the back half, just like we did before. So I'm going to ignore the back half and just look at the front half. 3a squared b minus 18a. And I see I've got a factor of 3 and an a in both of those. And let's see what's left when I've factored those out. I'll have ab out of the first term, and then here 18 divided by 3 is 6, and a divided by a is 1. Okay, not so bad so far. And then here I've got these two, and I got 30 and I got negative 5ab. They both have a factor of 5. So I'll go ahead and pull a 5 out. I'm left with 30 divided by 5 is 6. And then here I'll have a negative AB. I stop there and I go, well, everything's great except that AB minus 6 is not the same thing as 6 minus AB. This is a stupid one. What's the deal with this? It's fixed time, folks. Fixed time, I tell you. We can fix this. When these are the same values, but they're opposites, the signs are the wrong things, we can take one of them and we can switch the signs. Or, in essence, we're going to factor out a negative 1 out of this thing. It's going to change it so that our AB minus 6 is the same way we can regroup. So here's what I'm going to do. Instead of plus 5, I'm going to imagine I factored out a negative 5. We're going to factor a negative out. That would give me a negative 6 plus AB, which now all I would have to do would be to rearrange this part right here, AB minus 6. I'm allowed to do that. And now I've got the same outside or inside the thing factors, and I can regroup this 3a minus 5 and AB minus 6. Totally legal. Totally legal. And if I had started off with sorting this out differently, then I would have seen that more obviously. For instance, there's our answer. You can go back and see what we did there. But if I back up here and I switch these two out and I go, let's do the negative 5ab first. And then what was in there? Plus 30. Okay. Maybe I would have taken out a negative 5 right here, and that would have left me with AB and then 30 divided by negative 5 would be minus 6. So maybe you wouldn't have seen that going into it. Maybe you're like, I don't know what to do. I'm just going to go with the way it is, and you end up with those opposites. You can always switch the signs. That is, imagine you're pulling out a negative, and all these things, their signs switch so the thing kind of like turns around and is exactly what you needed it to be in the first place. Yeah, so that's the thing. You're like, do you take out a 5? You take out a negative 5. A negative 5 would be better. If I had the 30, I'm not really thinking taking out negative 5, but you can fix it. You can tweak that as you go along. So there you go. I'm going to clear the board and set it up for example 5 here. And we'll spend a little bit more time on that one because it does tend to have some little tricky things and new concepts to deal with. Just kidding. I'm not frozen. Wait. So if you're talking about... Oh, no, it's not stuck either. I was just kidding. Now we're going to take up a thing that's a trinomial, and we'll look at a very specific kind of trinomial. Trinomials have three parts. We're still talking about polynomials. So this one's called a trinomial. It's a very specific kind. It's the kind that makes a parabola if you graphed it. It starts off with x squared, and then it drops down to x, and then it has a constant at the end. We'll have coefficients as well, a number out here in front, which we'll call a, and a number right here called b, and then our constant again. Three parts, makes a parabola. Parabola involves squaring, so we're going to call them that's square, quadratic equations. Very special. We factor these a lot, right? I'm going to give you two examples of these and how we're going to go about factoring these things. Okay, I'm going to take these two examples. These are two examples of quadratics. 2x squared plus 11x plus 15. I'll take the harder one first, and then we'll do this other one. So I'll copy that down here. 2x squared plus 11x plus 15. If I line stuff up here, then a is 2, b is 11, and c is 15. Okay? Alrighty. Now, the way that this one works is we want to eventually break this down into those two pieces, just like those other ones where we had 4. It's just there's two middle pieces that'll be like each other, and will get put back together when we FOIL it. So really, there are 4 parts here. We can only see 3 because this plus 11x is actually made up of 2 things that have been put together. And we'll show you that when we check our work. All right. Now, the way with these trinomials, these quadratics, is that we are going to factor them by starting out by looking at the number in the front and the number at the end, the 2 and the 15, or the a times c. And in this case, a times c equals 30. 2 times 15 equals 30. Our job then is to find out what those middle pieces were that make up 11x. We need to split it up so that we have 4 pieces like we had in the other problems. And then we can factor the front half. We're going to factor the back half separately before we put it back together. The trick here is to find factors of 30, that is 2 numbers that multiply to 30, that when added together make 11. So I've set up this little thing. Maybe you've done these in elementary school. I know some of my kids have seen these before. And so we got what factors of 30 would add together to make 11. Now there are a lot of possibilities. You can have 1 times 30 is 30, and 2 times 15 is 30, and 3 times 10 is 30, and 5 times 6 is 30. And you can have both of them being positive and both of them being negative. They still will multiply together to make 30. But what we're interested in is when I take any of those factors and I add them, I need to get 11. So which one of these ones would add up to 11? Well, this one adds up to 31, and this one adds up to 17, and this one adds up to 13, and this one adds up to 11. That's the one that we need. And now we can rewrite this problem. We rewrite the part at the beginning, we rewrite the part at the end, but we're going to leave 2 spaces for the stuff in the middle. And I'm going to put a plus 6x here and a plus 5x there. So I used these factors that I found, and I'm going to say, well, the middle piece was actually 11x, but it's broken up. I'm going to break it up into 6x and 5x because those 2 factors equal 11 and multiply together to make 30. That's the trick. That's the thing that we're looking for. So now we go and we split this up and we factor it in the front and in the back. And we see that we're doing pretty good here because we can rewrite this as 2x and 5 is being multiplied by x plus 3. Now if you want to double check, you can. You can do first, then the outside, then the inside, and then the last. And these 2 are like terms, and we get back to where we started from. This is the trick right here. we have to take A times C, the first number and the last number, take that number and then break it down into all the different factors that would multiply together to make 30, and find the two that add together to make B, to make the middle number. We can rewrite it then any way we want to with 4 pieces and do our factoring and combining. If you need to check that again, just back up a couple minutes and rewatch that. That's our trick. Now, the second one is a little bit different because the number that's in front, the value for A in this case is 1. The same rule still applies, but we usually only think about this last number. But I'm still going to think of it as being 1 times negative 44. That is, A times C equals negative 44. Now we need to split up this negative 7 into 2 parts so that we can factor this front half, back half. And we need to look for 2 factors that multiplied make negative 44, but added make negative 7. Well, since it's a negative, I could have negative 1 times 44, or I could have a positive 1 times negative 44. Those don't sum up to negative 7, so it must be something else. They sum up to, well, 43 or negative 43. So those ones don't work. I'm going to keep going. Negative 2 and 22, or 2 and negative 22, do not equal negative 7. So I'm going to keep going. Negative 4 and 11, or 4 and negative 11. This one sums to 7, and this one sums to negative 7. And so therefore, that's the one that I need. I need to split up negative 7x into a 4x and a negative 11x. So I'm going to rewrite this, 1x squared, or just x squared. And then what should I put next? It doesn't really matter, so I'll just go in order. Plus 4x minus 11x minus 44. See, that still sums to negative 7, but I've broken up into 2 parts so I can factor this. I'm going to factor the front half by factoring out an x. And that leaves me with x plus 4. Out of here, I can factor out a negative 11, and what does that leave me with? X plus 4. The distributive property says that I can regroup these things as x and negative 11 are both being multiplied by x plus 4, and there we have our factored version. We can FOIL that back together to see if we get where we were. First, outside, inside, and last, and then we recombine these when we get back to where we started. That one's a little bit more complex because you kind of have to start thinking about all the different factors until you get to the ones that sum to the number that you need. But the more that you practice, the more you'll get those a lot faster, and you won't have to go through like the entire list of them like this one here, or I did it over here too, but eventually we found the ones that summed to the right value. Okay, practice, practice, practice. That's what we got to do. So if you end up having questions, please come and ask those questions. The problems are all the same, just different numbers, right? We're going to follow the same exact process every single time until we find the numbers that we're looking for. And here that was a 4 and a negative 11. Multiplies to negative 44, sums to negative 7. There you go, and you're welcome.